as many other limits before, this limit here is the definition of the derivative of the sine function at the point A. And although is something that we have discussed in theory class, we're going to repeat it here just for completeness, right? The argument to calculate this limit is very simple. It's just we need to expand this, the sine of x plus a, as the sine of x times cosine a plus cosine x times sine a. And then we have to substitute it there, right? So we have sine x plus a minus sine a, that's equal to this first part, okay? And then we subtract sine a here. And you have sine a and sine a, so we factor this out, so we get sine x cosine a plus cosine x minus 1 times sine a. Okay? All right. Then we can put this in here and take into account that these two numbers are constants, because once we substitute a by x by a, right, in the argument of the cosine or the sine, and since a is fixed, it's a given point, this is just a number, and this is just a number. So these are two constants. So we can split this limit like this. That is the limit. Well, actually, we can factor out the cosine. So it's cosine a times the limit, sine x divided by x, right? Divided by x goes to 0, plus the sine of a times the limit when x goes to 0, and then you have the cosine x minus 1 divided by x here. Okay, there's x here. So we have to calculate these two limits now. Well, this first limit is 1, right? That's actually proving that this limit is 1 is how we concluded that the sine of x is equivalent to x when x goes to 0, right? So now we need to calculate the second limit here, okay? And we calculate this limit because we're going to use this equivalence. 1 minus cosine x is equivalent to x squared divided by 2 when x goes to 0. So that's an equivalence that you can derive once you know this equivalent about the sine and the connection between the sine and the cosine, right? Okay. Then all we have to do is to substitute this expression here. So this limit here is equal to the limit when x goes to 0 of, well, it's 1 minus cosine. We have the cosine minus 1, so it's minus x squared divided by 2 times x, right? The x in the denominator, okay? But you cancel 1x, right, up and down, and you just have this limit of negative x divided by 2, but then this limit is 0 when x goes to 0, so this one cancels out. So at the end, the conclusion is that the limit is equal to the cosine a times 1 plus 0, which is cosine a. And that is actually the derivative of the sine. The derivative of the sine is the cosine, and that's the answer that we have obtained here. This is actually the proof that the derivative of the sine of x is equal to the cosine of x.